Hello, everyone. Let's wait a minute, then we are going to start. People are still joining. All right, let's get started. Hello and welcome, everyone. Great to have you join us. This session is going to be about how to use UniqueSignal, our new feed with MISP, threat intel, and sharing platform, and of course the use cases around that. And a couple of housekeeping items at the very start. So this session is being recorded and will be shared afterwards, and slides will be included. And we'll have time for Q&A at the end, so feel free to type your questions in the chat anytime. So hopefully this will be a useful hour for everyone attending. To start with, so MISP is an acronym. What it stands for those of you who are curious, a malware information sharing platform. It sounds very, very relevant to us. So, and to be fair, I think it's more than that as of now, expanded to many types of intelligence, many use cases, especially across CTI ecosystem. And as we launched our new product, UniqueSignal feed, it was kind of a no-brainer to make sure it can be ingested by MISP as well as other tools, so they can play together. And on top of key indicators around the quality of the feed, so we're following some KPIs. So these were kind of the very important criteria for us. And Torsten is with us today to speak about those KPIs, some indicators, to speak more about that, as well as recent updates and future outlook for UniqueSignal. So moving on, and of course, we are excited to be joined by a special guest, Koen van Impe. He's really one of the core contributors of this open source platform, and I would say the CTI ecosystem. And he has decades of hands-on threat intel and DFIR experience. So happy to have you, Koen. Hello.
Thank you, Article. Thank you for the nice words, and happy to be here.
Yeah, amazing. So let's move on. I'm gonna hand over to Koen to dive into the demo, but first, let's start with a quick map of what VMRay provides today and an overview around UniqueSignal, just to set the stage. So deep response for especially the FIR and malware analysts. So if you want to have the full sandbox depth, behaviors, memory dumps, live interaction. So it's kind of used when you need to see and explain the full capability scope of the sample. And the final verdict is especially for modern SOC workflows. So you have high volume of samples, you gotta analyze and get the verdict. So API integrations, it can be connectors to other tools like EDR, SOAR, or email gateway, pipelines. It's really used when you need fast, like binary yes and no decisions around the sample. And Total Insight, especially, is used by teams that want both scale and depth. So it can be also used to create threat intelligence. They have high volume of samples, high volume of submissions, and as well as they would like to have analysis to the depth, so analysis detail as well. And some customers, as I mentioned, build their own threat intel tools, as well as build their own internal virus total with it. And the UniqueSignal is kind of the newest edition that we added in 2025, and it's kind of a new product and standalone malware intelligence feed. So I'm going to speak more about that right now, and why UniqueSignal, how it came to be. It's kind of always good to share the product story and the big bang moment, how it came to be. It's going to be quick, but our sandbox platform, it has been used across industries, and what we observed was some of the well-resourced teams have been using it for threat intel generation, and without too much like analysis paralysis, they trust not only the verdict but also the IOCs extracted from it, and less false positives. It can be easily used, integrated to other detection tools or threat intel platforms. So since you trust the output, you want to have this data, this intel, and used for different use cases. But kind of these customer insights made us think if we can provide more, making this intel more accessible to other organizations as well. And kind of the idea was born from that. And we, of course, ran interviews with dozens of CTI teams and noted down the problems we heard. So there were some problems really standing out. It was different organizations, but it was kind of same themes. And what were they? First of all, the problem around the atomic IOCs without any context. For example, there are IPs, domains in the feed without who, why, how, some answers to critical questions, or labels, for example, they were missing or inconsistent. I'm sure Kuhn is going to touch on those labels and how it looks like in MISP dashboard as well. And so without the context, it's hard to decide like whether it is to block or hunt, or we gotta ignore for now. What will be the decision? So this was one of the problems, and the other ones around the delay. So that the kind of intel lens after the campaign already moved, it was kind of not actionable anymore, and the IOCs are aging out really fast, and the useful window is short. So you gotta have the intel right on time. So another one is it was around the like duplicated like intel, like the open source intelligence. There are some open source repositories and stuff. So it was kind of a rehash of the same resources, and it's actually ending up with the same kind of IOCs in the feed. And there are multiple feeds watching these public repositories, public lists. And the community is always great, but we have also our own thread feed portal that we know that some threat intel vendors also monitor there as well. But the application isn't that good, especially for if you would like to have a good, useful threat intel feed. And another one, the problem around curation, we can call it like the curation tax. So it's not really most of the time for CTI teams to have some good intelligence. So it's not the processes are not like automation friendly, and the feeds are not automation friendly. So you gotta enrich and you gotta stitch some context on top of it. So this kind of not really Intel most of the time, is kind of the raw data. And as we all know, most teams don't have those spare cycles, so they want kind of playbooks and automation, that we're going to speak on that as well today. And the last one around the volume and the quality and that kind of trade-off, I would say. It can cause, for example, ingestion issues or like alert spam, let's say, like with all those false positives. So what we heard from customers were kind of volume is no equal to value, really. So when the volume is high, you're gonna pay in pipeline cost and analyst time, when you ingest everything. So this was kind of an overview around the problems that we observed before we come up with a product, with a solution. And here is actually what we focused to hit those marks. And I'm really happy that Torsten is joining us today to talk through around the KPIs, but this is kind of a summary. So there are kind of core principles that we speak here. So just context, uniqueness, timeliness, and of course, readiness for automation. So just one highlight around this, measuring uniqueness and timeliness really is hard to claim, but actually it's kind of easy to test. I will show that on the next couple of slides. So we use an independent third party to benchmark uniqueness and timeliness. So it's run by Tikura, and they track like first seen and also source overlap across over really 1,000 feeds. And why it matters, of course, high uniqueness actually means minimal duplicate noise. It can, coexist with your existing feeds, and also means this is the intel you can trust for. It's kind of a clue that you can trust this feed for blocking, not just enrichment. And also high fidelity means no false positive explosion in the SOC. Also, timeliness is strong. It's good, to cover early on fast-moving like malware infrastructure for sure. And Kun is going to talk about what use cases you can expect from such a feed. And again, Torsten will shine more light on how we make sure those numbers, like you see on the screen, 90% uniqueness, and what it means, to keep those numbers healthy down the road, and to make sure actually the ideal use cases are achieved, as you see here, at the blocking and early detection and DFIR investigations. I hope it makes sense until now. So we also found some real DFIR cases. What you see here, actually, proving timeliness is kind of tricky, but this is our best try. So what you see here actually from a real DFIR case from NCC Group, they published a blog post around this. What you see on the left is kind of the VirusTotal screenshots. When you submit the hash found in that DFIR case, you see there are no detections at that time. But on the right, you see the dashboard provided by Tikura, the independent third-party company, making these evaluations, comparisons. A UniqueSignal first seen actually on this hash 2 weeks earlier than the incident report window. So, this is kind of the only source at the time until the report is published. So this is kind of a good example on how a unique and timely feed can look like, and how you can measure it. And we are really happy to see there are more examples as we go forward. But for now, a bit around how it works behind the scenes. Again, to set the stage, it can be useful today. So our evasion-resistant sandbox is a huge differentiator here to come up with UniqueSignal. Of course, samples and sample sources, they are very important. We have multiple sources for samples, as well as a good process to triage the most relevant ones out. And all go into the sandbox that allows us to see the, of course, full behavior without any evasion setbacks. And we are able to extract the IOCs, which is kind of, course, boosting the uniqueness as you are able to analyze in the right way without any evasion tricks. But that's not the end, because before delivering it to the platforms like MISP, for example, it goes through false positive checks, enrichment and labeling, context linking, for example. So this all really helps and reduce the effort probably you are planning to you are doing for any feed out there, to enrich it to deduplicate or all those kind of stuff. And also Koen is gonna talk about that, I think. But this is also first layer of filter and a very strong layer of filtering and enrichment going on before delivering it to the other platforms. And I think that with this flow in mind, I will be happy to pass it on to Koen to show what lands on the MISP front. So he's going to walk us through really many things, but in a very effective way, how to set up use cases and the MISP playbooks, how it can play with those processes and automated playbooks as well. So yeah, Koen, over to you.
Okay, thank you, Ertugrul. So just a second while I share my screen. Can you just confirm that you have a view on a MISP interface?
Yes, Koen.
Okay, good. So as you already explained in the introduction, MISP is a threat intelligence and information sharing platform. You can use it for collecting, storing, and sharing threat information and intelligence. It's community driven and it's fully open source. What's important to know is that MISP can also support you through the entire intelligence lifecycle. So once you work your way through the direction phase, you can use it to collect threat data and roll IOCs from various data sources. Then you can start processing the events and then analyze the data information, transform it to intelligence, and disseminate it to your stakeholders. And you can use that information in intelligence, for example, for strategic reporting. MISP also has a feature to collect feedback from your stakeholders. Now, another typical approach is to operationalize the data and information that you have in MISP for blocking and detection purposes. That's exactly what I'm going to show you during this webinar. Some of the components that you can use to build your own CTI playbooks so that you can operationalize such data and, for example, use it for different use cases for threat analysts, SOC analysts, or CISR staff. If we talk about data collection, so first, there are a couple of ways to do that in MISP. In MISP, the primary way to set a data collection source is through remote service, which allows you to connect to one of the MISP communities. A MISP community is a set of organizations that share events among each other, for example, in ISAC. Within the MISP interface, but there is a list of communities, and if you want to join them, there's a button that you can click to just request access to these communities. Another way of defining data collection sources in MISP is through feeds. By default, MISP ships with a set of feeds that you can enable on your instance. For example, the OSINT feed from Circle, Tor exit nodes, the feeds from abuse.ch, threatview.io also has a good data set, Rusty. And then there is VMRay. VMRay UniqueSignal can also be added as a MISP feed to your MISP instance. To do that, it's very easy. In the feed menu, you have add feeds. I'm just going to zoom in a little bit to make it more readable. So once you add feed, you need to indicate to MISP, I want to enable the feed, and I want to look up data in the VMRay UniqueSignal feed. Then you have to specify a name. You have to give it a provider, so that it's clear for everyone from where the data is coming from. And then you have to indicate the input source, whether it's a network source or a local source. In this case, it's VMRay. So we're going to use a network source. You have to provide the URL so that MISP knows exactly where it needs to fetch the data from. So in this case, from the API from VMRay, and then the source format. MISP supports a set of formats to include as a data feed. But in this case, the VMRay UniqueSignal feed is in a MISP feed format, which makes the processing and analysis much more easier. So you don't have to do any special adjustments. You can easily use it to create the events on your MISP server. And then as a final thing, you need to add a set of headers. These headers, they contain an API key and a device ID that you receive from VMRay. Once you've added these headers, there's one last step that you need to do, and that is set the distribution level. So the distribution level in MISP that indicates with whom you're going to share the threat events. In this case, the events that we receive from VMRay, but we are not going to share them outside of our organization. So you need to set the distribution level is your organization only, and is not going to be distributed outside your environment. Once you click on submit, the data feed is enabled, and the processing, the collecting and the processing of the events from VMRay is going to start. Now, this training environment has already been set up for a couple of days. I've already collected and processed a set of VMRay events. So if you look at the data collection from VMRay, so for example, at first glance, it already gives us a little bit of an idea of what exactly that we received from VMRay. So during the processing phase, we add a little bit of metadata to all these events to indicate that we received this from VMRay. So for our analysts, once the processing is finished, and they want to go through the analysis phase, but they know, okay, this data, this event comes from VMRay. We received it through one of the MISP feeds. We consider the feed from VMRay as a trusted feed. We also indicate that the confidence that we have in the provider, in this case VMRay, that we have a high confidence in it. We use a multi-scale to classify this event. It comes from a high confidence provider. And then lastly, we also have a metadata that indicates that the processing of the MISP event that we receive to the feed is complete. So we use the workflow state complete to indicate processing is finished. Additional metadata that we also can notice on this overview screen is the number of attributes. So attributes that are in each event that we have received from VMRay. Correlations. Correlations in MISP is just an indication that an attribute that exists in one event is also being seen in another event. We have a date field and an event title, and also a little bit of contextual elements. So all the events that we receive from VMRay, there's contextual information added to it. Sometimes it's the type of malware, sometimes it's the threat actor, the type of attack pattern. So all this information that we can use to build our threat environment. Now, if we just jump to one of the events, for example, this event here from VMRay on Kaiserrat. So if you open up the event, there's an overlap of this event with all other events from VMRay. There's some additional knowledge that we can add here. And then also there's an overlap with OSINT feeds, which is a good example of the VMRay feed, UniqueSignal feed, doesn't exist on an island. So you use one set of information to build your knowledge. And then you have a set of other OSINT feeds, in this case, and one from Circle, one from Rusty, that builds on the knowledge that's being provided by VMRay. So with multiple sets that expand your horizon, that expand your knowledge, that if you put everything together, that give you a complete picture. Now, if you scroll down through the list event, we also have a modification map, which gives us an idea of how frequently that VMRay has updated this event. We also have a number of attributes, obviously. We have the context elements that we already saw in the overview. This event talks about Kaiserrat, XRAT, and then some of the attack patterns that we can observe here. Just moving the window a little bit to the side. And then we have the set of attributes that have been analyzed by VMRay. So in this event, there's set of, let's collapse it first. There's a set of files included with a report, a malware analysis, another file, another report. So all different types of attributes that we can use for detection and blocking purposes. Now, if we look at the details of the attributes that we have received, this is a file, we have a set of file hashes, the SHA-1, the MD5, just zoom in a little bit so it's more viewable. So we have this file hash, and according to VMRay, this is Kaiserrat. and it has been identified as a backdoor. And also VMRay gives us a set of detection rules that we can use if we want to use this in our own environment for detection purposes. Now, these are the elements that we need to look for. So we have VMRay telling us it's Kaiserrat. And as an additional source, we also have malware-bazaar telling us exactly the same. This is also Kaiserrat. So this is exactly the same as we're using different feeds to extend the knowledge that we get to VMRay. VMRay provides us one point of view. And we have another feed here, malware-bazaar, which confirms that the analysis is being done by VMRay. Correct. And it's also Kaiserrat. So this allows us to improve a little bit the confidence that we have in this information and use it for blocking purposes. Now, if you want to track, for example, what is going on in the threat landscape, and you want to build a daily picture of what type of attack patterns are used. This sample includes process injection. We can use one of the MISP features to pivot to what is process injection. Them out a little bit. So we get a description from MISP, that process injection is exactly this. And then we have a list of events in our environment that we can use to track what exactly has happened today, the last couple of days on process injection. We have an event here from the cybersecurity from Belgium on process injection, one from VMRay that we just highlighted, another one from the CCB from Belgium. So using VMRay as an initial point of entry, which explains us, okay, process injection has been used in this event. And then we use the MISP pivoting features, galaxies and clusters, to get a picture, okay, which are new events that are coming in our environment. If we go back to the data collection of VMRay. For example, if we take this first one on REMCOS. So this is another event from VMRay that we received with a couple of attributes. And this event, but MISP highlights, there's likely false positive, which maybe is a little bit strange because we get this event from VMRay. So having notification that is likely false positive is maybe a little bit strange. But if you scroll down and we get the explanation, why exactly is this a false positive? I'm zooming in so that it's more readable for you. If we look at the reason why MISP thinks that this is likely, that this event contains a likely false positive, is because of this IP address, 2395. MISP sees this IP address as part of VPN provider IP addresses. Now, IP addresses belonging to VPN providers, their lifetime, their usability for blocking purposes is relatively limited. So using this IP address to block it on the firewall, maybe not a good idea, especially because if you look at the classification by VMRay, they indicate that currently the IP address is offline, is being associated with a backdoor, REMCOS. So maybe using it for currently blocking it on your firewall, not such a good idea. But if you look at the other data that we also received from VMRay for this IP address, it has first been seen on the 12th of November. So maybe it's a good idea to use this IP address, not for blocking, but for historical search. So if we have our firewall logs or SIEM logs, we can use this IP address to do some kind of a retro hunt or retro search. Did we see this IP address in the past? If we see that, but we know that we might have some problem with one of the infections on our environment, that REMCOS might be on our organizational network. Now, to do that, we can use this IP address and send it through Teams to our colleagues from the SOC to do a hunt, but that's not really going to work. So in this case, we're going to use the automation feature from MISP. MISP has a workflow setup where you can execute a set of automatic actions following a specific trigger. In this case, an ad hoc manual trigger, but you can also automate this. And we first search for the retroactive search to SIEM. And I know this is a little bit small, but just to show you the different blocks that exist here. So in this workflow, what we do in MISP, we verify, is the information that we have in the event credible?
Koen, may I jump in here with a question?
Yes, sure.
As you're going like straight very fast, so I don't want to miss an opportunity actually to actually discuss one important thing. So you mentioned that actually MISP kind of on the top right, we have seen that it's potentially false positive. And while explaining that, actually you kind of explained I would say, actually, my question is it's the typical approach for MISP to use the feed for blocking. So that's why what we see there on the top right, if it is something that you can block, so it's kind of highlighted. So is it the case? Is it kind of the priority use case for MISP to use feeds for blocking?
I would not say the only priority use case. It's definitely one of the top cases. So using it for blocking, but also for doing, for example, a search in your historical data, as I just explained here. But using it for blocking, yes, definitely. MISP can be a very good aggregator of different feeds, and then you normalize it a little bit. You remove those likely false positive. So the ones that come built in, the checklists that come built in with MISP. Some of your organizational assets, some of your peers, for example, you remove those indicators from the list if you receive that from an external one, and then use it for blocking purposes. Yes, exactly.
All right. Okay. Good to know.
Okay. So, if you just talk about the workflow here in MISP, so what happens here is we look at the source credibility, we extract the network indicators, we make sure that they are actionable, and then we push that, and just zoom in at least so that it's readable. Once we have those network indicators, we push that to a list that our SIEM then can use to do a query. So I'm not going to go through how to implement it in a SIEM, but it is just a simple text file that your SIEM can use to do a query on. So we have this MISP event from VMRay. We want to push this as an historical search action. First, we're going to indicate, again, using the admiralty scale. So initially, during the processing, we already indicated VMRay. We have high confidence in it, so it's a high quality source. But now we also need to confirm that the information in this event is credible, is likely true. So we set the admiralty scale to true, and now we execute the workflow. And before I execute the workflow, just to show you that it actually works. So this is the current text flow. So 2 IP addresses that I have in here. If I execute the workflow, search it, put it to the scene. So if you scroll down to the IP address that we have just sent to the historical search, we have a course of action, passive course of action. Look it up in the firewall. If you open up that list, that IP address is added, and now your SIEM can pick up this list and can use it for historical search. We also add an analyst note here in MISP just for our analysts to review later on. Okay, the network address has been seen, and we have done a search in our historical logs. So this is for IP addresses, sending something to a SIEM search. Can do the same also for a firewall blocking environment, but time is short, so I'm just going to show you now another use case. So instead of pushing something to a SIEM or to a firewall, you might have a case where CSERT does an investigation. They've analyzed 2 infected systems, and they've been able to extract malware samples from it. So first execute playbook. So they have extracted 2 malware samples from it. One from our finance workstation, one from our legal workstation. So 2 samples. We don't know what these samples are. We just know that they triggered an antivirus. We want to know a little bit more about it. For that, I'm going to use one of the MISP playbooks. These playbooks, they exist on GitHub. A couple of samples have been published there. So what this playbook does, it's going to load these samples. It's going to attach them to a MISP event, and then we can further do the analysis in our MISP environments. Just executing this playbook. There's a little bit of Python code behind it. If you're interested in that Python code, just go visit the MISP Playbook website. In this case, we have 2 malware samples. We extract the hashes from those samples. We attach them to a MISP event. We extract the PE headers, PE imports and exports so that we have at least a report. And we push that all to our MISP environments. Now we go back to MISP. There's one event that's been created, and already at the overview of the event, so without going to the details, but we see there's a little bit of correlation in it. If you open that event, we've added 2 samples to this event from our CSERT investigation, 2 samples extracted from a workstation, and MISP indicates these samples, but we only have the hashes, nothing more, no further analysis. But there's a report from ANLAB that talks about some of these samples apparently. One from ThreadArray. We have two samples, two reports from VMRay that also gives us info on the samples that we have just extracted. And also the Rusty tells us a little bit more about it. Now, if we scroll a little bit down to those two samples, we have the one from finance department, correlation, we have the hashes here. Then we have another one from our legal department. Let me scroll to the right so we can see it. So this malware sample, we have the hash. VMRay has seen this hash. So what exactly is this malware about? We are not going to run it in sandbox. We're just going to use UniqueSignal as a feed to know exactly what is this sample about. So this is the VMRay report. We scroll a little bit down. This is a sample that VMRay has detected. We have analyzed it ourselves. So just to make it sure for you. So we have just uploaded to our MISP events. We have not done anything else. We're just using the feed from VMRay. According to VMRay, this is Remcos, categorized as a spyware. And what's very interesting, so VMRay tells us this is Remcos, spyware. We also have Malware Bazaar telling us exactly the same. So again, it's always the same approach, but we have one source telling us it's exactly this type of malware, this type of threat. And we have a second source, in this case, Malware Bazaar, which confirms, okay, this is something that we want to block in our environment. Now, in this case, instead of sending it to a SIEM for the historical search, we're going to send it to Sentinel and Defender. Again, using the same approach as sending it to the SIEM. We're going to use the MISP workflows. So first, we identify the source, VMRay, high confidence in it. We also, the information in this event, we also want to confirm that it's probably true. So we set the information credibility to 2 for admin scale. And now we use another MISP workflow. And let me find it here. Another MISP workflow, which is going to synchronize everything that is in this event. So we have the IP address, we have the file hashes here, and all the associated information from VMRay. So not only the one that we have found, but all the other associated information. We're going to send all that information to Sentinel, and then we can do that, can use that information there further for our investigations. So pushing it to Sentinel takes a couple of seconds before it is uploaded to the cloud. We add an analyst note that later on, we know, okay, this information has been manually synced to Sentinel. And if we now jump to Sentinel and do a refresh. So this is one of the indicators that was part of that event that we just manually synchronized to Sentinel. So very simple approach, very simple components also to build your CTI block workflow. We have threat feed from VMRay. We have malware samples that we uploaded. We've not done any malware analysis, any investigation, just the file hashes. We have information from VMRay telling us what type of malware that it is. In the event from VMRay, we have additional indicators that we can use for detection and blocking purposes. And from our MISP environment, we use one of the workflows to push all that information to Sentinel, and so that the SOC analysts can do their work there in Sentinel. Many other features obviously available through the MISP workflows, and I can go on for a couple of hours if you want me to grow, but I guess I'll pass it on now to you to explain a bit more about VMRay UniqueSignal.
Amazing. Thank you, Koen, for the great insights, and definitely we will need another couple of hours to go deep dive into what you can do. But what you just were able to show was even very, very exciting, and I think were very useful stuff. So thank you for that. Torsten, we will pass it on to you to walk us through how we maintain the quality of the feed and how we measure the numbers going forward.
Yeah, thanks, Ertu. Koen, and hello everyone. So yeah, I'd like to build on the slides that Ertu presented last before the demo, and I'd like to zoom out again a bit and look at the broader picture. We've now seen in detail how MISP and UniqueSignal integrate, and yeah, thanks again, Koen, for the really excellent demo and walkthrough. It's really good to see this thing live in action. and related to real use cases. And yeah, I used the final minutes of the webinar to highlight a few KPIs of UniqueSignal, also share recent release notes and give a brief preview of the roadmap that is upcoming. To reiterate the workflow, so we collect the samples from the wild, process them in our sandbox, detonate them, and then publish the results. And in addition to the MISP feed, we support multiple export formats such as STIX-TAXI and also JSON CSV. And this allows the data to be consumed by a wide range of tips. Some of them are OpenCTI, Thread Connect, Splunk, and ThreadQ. So now looking at the, having looked at the integration points again, let's shift our focus more like how we ensure the quality of the intelligence behind it. To do that, I'll move to the next slide and walk you through the KPIs we monitor, why we track them, and how we guide the product development with the help of them. So on these slides, there are some KPIs we track and explain the reasoning behind them. We of course track a lot of more in the background, but I try to focus to keep the most interesting one highlighted. So first of all, of course, we look at the major IOCs, such as the number of reports and total IOCs generated. We monitor these figures to ensure that we maintain an sufficient volume. Currently, we produce around 5,000 reports per week and roughly 20 to 40 K IOCs. And again, one report that represents a single detonation, and along with all the IOCs observed during that observation, that will generate then the IOCs. Those numbers are then used going into the numbers of uniqueness and timeliness, which I discuss next. We also recently hosted a webinar with our partner Decura, and they went into the super detail on the key matrix of uniqueness and timeliness, and both are related to our feed. And the uniqueness refers to the IOCs that are seen exclusively in our feed. And then the combined timeliness refers to additionally the IOCs we see earlier than others. And we know that's really important to have this to get analysts with IOCs that are still relevant and also can be used for blocking to prevent malware from spreading and make detection possible. And we keep those values typically about 90%, which is then critical for delivering this high actionable TI. Another number we also track is the malware families we identify, and that's a KPI that ensures that the intelligence we provide is enriched with enough context to be meaningful. Our target is here at least a cover of 60%, but mostly we are above it. And we also monitor the distribution across individual machines, families. And we recently also invested a lot of effort in our family detection. And I think the impact is clearly visible. So the family labels are now very accurate and they are on point. There are no generic labels in the thread. So it's a very reliable thing. And overall, I believe that the consistent measuring and reviewing these indicators is really essential for keeping the product in a strong shape and guiding the development to the next stages. So now that we've briefly looked at the key indicators that help us maintain and improve the quality, let's take a look at the latest updates. So the next slides will cover the recent release notes, highlighting a bit of the improvements and the features that are also directly supporting the KPIs we just discussed. There are 3 categories where we made improvements, and I go over each of them now. The first is is listing improvements in the area of expanded classification and attribution. we added industry labels and country-level stick sightings objects, and these give more detailed context around indicator, helping analysts to understand where and how threats are affecting specific industry sector and region. That's also important to filter out IOCs that are might be not interesting, as we all know that some systems have a limited ability of ingesting IOCs. So yeah, you probably can't ingest everything. So you always have to look and balance it out. And this should help with it. Also, we added an MVP of the threat actor attribution. That means indicators. Some indicators now include information about the likely threat actors, and that would also supporting making it easier to assess and prioritize the alerts. The second area we improved is the indicator efficacy. And based on the KPI, we implemented a multi-layer confidence control mechanisms in our internal pipeline. And also we fine-tuned file indicators related to memory presence, to increase the quality of our IOCs, to make sure that every IOC in the stream has a certain quality, tells a certain story, and is also equipped with enough context. And this means we can now deliver more IOC volume for broader coverage without diminishing the quality. And to make sure the feed is covering the right recent malware samples, we also extended the variety in our sample sources. That's all like a well set up pipeline around our core technology that provide then a good IOC stream to ingest. The third area for stronger data structure integrations, we invested effort in new sticks objects to make full use of the stick standard and map our information in the best way possible, so that it can be consumed easier, because we learned that sometimes the sticks is not fully used. It's sometimes more like an extended CSV, and when we put all the context in there, we really learned that we have to use a variety of objects, and also need to make sure that those can be imported. We also have released a feature that makes the sticks a bit easier, because sometimes they are complex pattern with multiple hashes, but sometimes there's only limited support for one hash. So we also have like a solution for that if it is imported into firewalls or EDR systems with limited stick support. And to strengthen also the native integrations that support the context we deliver with the sticks. We had to improve or trigger improvements in Open CTI Thread Connect. And for MISP, we also improved our feed. For example, the labels that Koen just presented that tells analysts why we think a certain malware is a malware, or what the actions are. They were created a special format just for MISP to make sure that is shown in a good way and according to MISP standards. So having covered the latest release notes, we can use the last minutes to take a look at the upcoming roadmap. I share only the highlights, and of course we need to keep in mind these are plans, can still change if we need to adjust priorities. So through many customer conversation, we've learned that they are most interested in threat relevant to the industry and country. So that's why we want to continue to improve the already released feature where we enrich indicators in UniqueSignal with a target or victim industry information. And that's something that we think is very important. So we're putting currently here a lot of research into it to broaden the coverage and also the precision of the enrichment. And the second point is that customers can get a lot of alert from various streams, sometimes and without extra context, that's very easy to get lost. So to help there, we plan also to add more and better threat actor labels to the indicators to give a better context for the prioritization and also for understanding when there are campaigns behind it, so that analysts can just respond better and faster. And on the integration side, there are some platforms that still need some adjustments to pass, like the sticks format that we use, and or they have some limits that needs to be extended. So there are on our integration roadmap are the anomaly tip and the Sentinel-1 EDR. So and there we continue our journey to improve these integrations. Yeah, and by continuously monitoring the KPIs, releasing updates, and planning future enhancements, we ensure that UniqueSignal keeps delivering the high quality, relevant threat intelligence that helps our customers to stay ahead of the threats. And that concludes also my part, and I hand it back to R2 for the closing remarks and I believe a Q&A session.
Yeah, thank you, Torsten. So we're gonna wrap up with some questions. So I think I'm gonna share again. All right, so let's jump into the Q&A. The first thing first, so the session, as we said earlier, has been recorded, so we're gonna share the recording afterwards. But we got a couple of questions here. First is actually to you, Koen. So around MISP, what minimum processes or policies, for example, should an organization have in place before, starting the journey of deploying this? And also related to that, how much effort does MISP actually require to maintain?
That's a tricky one. I'll answer the first one. Policies that you need to have in place, false positive management. So regardless how good that your feed is, there's always going to be a false positive, also because that is very contextual dependent. So what is a false positive for one organization for blocking is, for example, not a false positive for another organization for intelligence purposes. So having a policy on how to deal with that, how to track them down, and how to react on it. Data normalization, so having multiple data feeds, making sure that you just have one data feed that is usable. Contextualization, so having a process that adds additional context to all your feeds. And as Torsten already highlighted, the labels that are added by VMRay to the MISP feed, they already provide a good context. But combining that with, as I showed in the demo, with the data from Malware Bazaar, other feeds, so that if something happens, your analyst has a clear view, okay, this is the context, and that they don't have to do that manual search when there is an alert, that you immediately, there is an alert, you get all the information from your tip from MISP, and immediately the analyst can get started. And having a process there that they know which steps they have to go through, which kind of verifications, which kind of enrichment, manual enrichment they have to go to. I think that's one of the first steps. So instead of, we all like deploying tools, that's fun. But having a tool and no process associated on how to use it, I like that false positive management, and knowing how to react after an alert. Then you have a shiny tool, but not really integrated in your organization. Is MISP tough to manage? It's a stable system. So if you poke around with a lot of the libraries and the dependencies, but then after a while it's going to break like every software package. But it's a stable environment, which if you do the updating right and you have a test environment, in the end, it doesn't require that much effort. There are also a couple of providers that can help you with that. And the MISP project itself, they have a lot of, so there's a GitHub issue tracker, there's a chat channel. So if you have problems, you can always reach it out there. So there's a lot of community support and also commercial support. So I'm a little bit biased, but in my opinion, it's relatively easy to manage, but you have to think about a little bit how you want to implement it within your organization.
Right. And I think if you are, for example, still using Excel to keep the IOCs and all that context, and probably you might need to think about deploying MISP. So it might definitely help. And so I think following up on that, Koen, so I think the running the playbooks, I think that's the second stage, right? When you start the MISP journey. So do you think it's kind of stage by stage, or you can just start it right away, like with the playbooks?
No, it's definitely a stage by stage, and there's also a little bit how MISP is built. So if you look at how it technically works, so it allows you to first start consuming intelligence. So you just set it up, and you pull in data from those MISP communities or the MISP feeds or like the VMRay UniqueSignal feeds. You just start consuming it, and once you see what the errors that other people make, so you observe how other people share data, and you can learn what works, what doesn't work, but you can use that to improve your own approach on using MISP. And once you've grown a little bit more confident, you can share back to the community. And sometimes sharing back can just be like a citing, confirming to another organization what you have shared. We've also seen it in this environment. And then slowly you can start building your own threat intelligence. And that's when you start building your own threat intelligence, that using those playbooks comes in play. Doing it from the beginning, but like every platform, it's stable, good platform, but you need to learn how to use it. And immediately jumping on the platform with all the playbooks and the workflows, you're going to get lost. So doing that step by step, that's definitely the best approach.
Yeah, that makes sense. And the last one, again, Koen, to you. So if you believe that 2 MISP instances are a minimum requirement if you want to do proper curation of feeds. So there were some talks about the curation process, and their architecture used 2 or even 3 MISPs chained together. So
yeah,
what would you say about that?
Yeah, that's an approach that I always advocate to organizations also, to not set up one MISP environment. I always try to explain, like, you have a dirty MISP, which connects to that outside world and which collects all the data feeds from various providers, some good, some not that good, but you collect the data from external providers. And on that dirty MISP server, you do the validation, like that processing. And once you have the processing finished and you have validated events where you have weeded out all those false positives, you add a little bit contextualization. That set of data and that set of information, you synchronize it to a good MISP, which you connect to your internal resources. If you're going to use external feeds and you push them immediately, one of the questions you asked, can you use MISP for blocking? Yes, definitely. But if you use everything from an external provider and you push it without some kind of validation to your security control, that's going to be a nightmare for your SOC and for your CSERT. So having a separate system validating and then having cleaned up data, curated data, and sync that to your internal MISP, I think that's definitely the approach that I advocate to all the organizations to set up MISP.
Amazing. So, all right, I think that brings us to the end of today's session, and big thanks really to you, Koen, for the demo and insights, and thanks to audience for the questions, and of course, Torsten for sharing the product vision and updates. So just one note, you can mark your calendars. We have a couple of, actually, we have one more webinar this year also, so you may want to join. And also, if you're heading to Black Hat London or CTI Summit in the US, so feel free to connect us there. Again, thanks for joining, and see you next time.
You're welcome. Bye-bye.
Bye.
Bye.